Welcome Professor Sai and lab mates to my first presentation in the seminar course. My name is Tran Minh Quan, but you can call me Harry. I'm the second year master student in Department of Biomedical Engineering, and I'm currently working in Lab 510 in Bioscience Building under Professor Shao's supervision. For the content of my presentation today, we're including my self-introduction, my background, the introduction to the technique, and domain knowledge in my topic, which is the zPDX technique, and its application in biomedical research and the novelty of the technique. And I will start this presentation by introducing myself first. So I will tell you a little bit about myself and where I live, and hopefully one day you can come to where I live to visit. Born and raised in Ho Chi Minh City, which is one of the largest cities in Vietnam. Vietnam is a Southeast Asia country. We are neighbor to China, Laos, Thailand, and Cambodia. And my birthday was 11 November 2001. And one of my favorite activities is running and food explore, which is I very enjoy in Taiwan. Is the food, the night market culture. I want to talk a little bit about my hometown, Ho Chi Minh City, or the Vietnamese local they prefer calling the name Saigon. When you go to Saigon, it's in the southern of Vietnam, and you can find some very interesting and famous food in the world, Vietnamese food in the world, like pho, Vietnamese pho, or banh mi, or Vietnamese coffee. And you can visit some very beautiful place, like this. I have an image about the Notre Dame of Saigon. It's in the center of the Ho Chi Minh City. And for my education background, from 2019 and to 2023, I was studying in Industrial University of Ho Chi Minh City, and I was major in chemical engineering. And my thesis and my research field back then is what material and application for wastewater treatment. And from 2024 to 2026, I was pursuing my master degrees in Trung Nguyen Christian University in Department of Biomedical Engineering. And currently my research field is the wound healing and study with the animal model, specifically is zebrafish. So the technique that I select is zPDX. So what is zPDX? It's short for Zebrafish-Derived Xenograft. zPDX is not a new technique. It's a well-known advanced technique in precision medicine with a rapid and cost-effective tumor modeling. So what is the zPDX model? So zPDX, using zebrafish as a main animal model, is provide a cutting-edge method for transplanting human tumor tissue into zebrafish embryos, and nowadays it's used to evaluate drug response and model tumor progression. And because of the zebrafish, is provide like a rapid, a cost-effective, and personalized insight into cancer treatment. So why the zebrafish? Why do you use the zebrafish for this research? I also do some experiment with the zebrafish model. So let me tell you a little bit about the advantage of the zebrafish model over the traditional model. So the first and the most important thing is they share the similar genetic to us is around 70%, and the transparency of the embryos is allowed to do real-time imaging, and they have a very short development time. So the tumor respond in 48 hours compared to weeks in mice, and ethical and cost-effective compared to the immunocompromised mouse model. So let's go back to our technique, which is the BDX, and back to the scientific discovery. So the first report patient-derived xenograph is according to the definition of BDX. Model could be tracked back to 1969 when Rigard and Bosevan removed the colon adenocarcinoma from the patient and planted to the tumor fragment into nude mice. So according to this, the first model they use is mice, and this is the image of Jorgen Rigard, which is the professor in pathology. So how does this work? So based on this reference paper, I have summarized the technique into 6 highlight steps like this. So hope on this 6 step you can understand the concept of the technique, because I don't want to go too deep detail into the step by step, but the main concept is to transplant the tumor tissue from the colorectal cancer patient into the zebrafish embryos. And using the zebrafish embryo as a fast and cost-effective model, we can predict the patient-specific chemotherapy response and in such a short, and we can save a lot of money by using this. So basically, for methodology, the step 1 is to collection the tumor. We can collect the tumor from the patient, of course, and we can obtain from the surgery. And the second step is the tumor preparation. So the perfect size for injection into the zebrafish embryo is from 1 to 3 cubic millimeter fragments, and we can scan for imaging using the cell tracker. And step 3 is the xenotransplantation. So the tumor piece injects into the perivitreal space up 2 days old zebrafish embryos, which is the 48-hour post-fertilization. And usually for zebrafish research, 48-hour post-fertilization is the perfect time to do research, to watch and to observe the reaction of the zebrafish embryo to the drugs or the treatment. And step 4 is the drug treatment. So chemotherapy regimen applied directly into the zebrafish water. So in zebrafish research, we call this method is water exposure. So this is one of the oldest and most effective way to administration the treatment or the drug to the adult or embryos. So step 5 is the tumor response assessment. So we can measure using the fluorescence imaging or volume tracking. And step 6 is the clinical correlation. So comparing the zPDX response with the patient treatment outcome. And on this reference, and through the result part in the reference papers, we can find some key findings from the zPDX study. So in the paper, they say 75% of concordance between the patient cancer patient chemotherapy response and the zPDX model prediction. Personally, I think this is quite high similarity between the prediction model and the real case cancer patient response. So I think based on that, we can conclude that zPDX is a good technique for the prediction of the outcome for the cancer treatment. In this case, which is the colorectal cancer. And the second they conclude is for the case colorectal cancer patient using the zPDX technique is phylloxera is the chemotherapy show the highest tumor reduction rate in the zPDX model. And the third conclusion, which is like a note, like the tumor engraftment success vary by the patient tumor type and the microenvironment factors. So these 3 conclusions can help for further research using the zPDX technique to screening more cancer outcome. So what is the key advantage of the zPDX compared to other traditional model? Like I mentioned before, the first model they use when they find out about the PDX is mice. So zPDX saw some key advantage in tumor microenvironment reservation compared to the cell line and the mPDX. And the speed and the scalability, the zPDX result only in 5 and 7 days, and versus the month in mPDX, and high throughput in drug screening due to the small embryo size. And mPDX require 3 to 6 months for tumor development and drug testing, which is way longer than the zPDX. And for the sample requirement, like I said before, zPDX only need 1 to 3 cubic millimeters for the injection into the embryos, and mPDX need a larger size of tumor because the size of the model is bigger. And the fourth thing, I think a lot of researchers will like this, is the cost effectiveness. So Zebrafish costs only $1 per day to maintain versus $1,000 plus for a month for mice. And this is the table that I summarize the advantage of the zPDX model versus the traditional model. So some aspect is like the speed, the cost, the ethical concerns, the tumor environments, the scalability, the imaging and personalized medicines. So what is the novelty of the zPDX technique? So like I mentioned all over again my presentation, compared to the traditional model such as the mPDX model, which can be expensive, slow, the result can be obtained in months, require the immunosuppressants, the zPDX model can be fast, result in days, cost-effective, and maintain the tumor microenvironments, which is very important for cancer research. And the breakthrough application of the technique is help us to identifying the optimal treatment regimen for the patient, cancer patient, which is have limit of time, and testing the novel cancer therapy before the clinical trial. This one can help to save a ton of money for a company, for a cancer researcher. And third one is to predict the resistant mechanism across different type of tumor, different type of cancer tumor. So what is the technique application in biomedical? So of course the most important thing and the highlight that I select for this is cancer research and precision oncology, drug development and toxicology, infectious disease and antimicrobial research, immuno-oncology and cell therapy, and so on. So the future direction and clinical translation for the zPDX technique is to expanding the technique to other cancer types, for example breast, lung, or pancreatic. Or we can investigating the immune system interaction using the adult zebrafish. And I want to mention that even though they are different development stage of the same animal model, but the adult zebrafish can be very different to the embryos. So it's open a new path of research, and we can developing automate high throughput screening for drug discovery, and the clinical trial interacting zPDX for real-time patient treatment optimization. So based on what I understand about the technique and the reference papers, I can give you some conclusion. So zPDX is a powerful tool for personalized medicine and cancer research. Because it's faster, cost-effective, and more predictive than the traditional mouse model. And it's highlight the potential of revolutionized oncology by enabling patient-specific drug testing. And it's opened the path for further research to expand the clinical application and refine methodologies. And through my short presentation about the introduction to the zPDX technique, hope you guys can understand the concept and the goal of the technique. Thank you, Professor Sai and LabMate, for listening to my presentation about the introduction to the zPDX technique, and hope you will get a good weeks in research, in teaching, in work. And once again, thank you so much.